Okay, so we're going to now talk about properties of logarithms. We will sometimes need to be able to figure out what a logarithm is equal to, but we won't know the exact value. And our calculators won't be able to tell us because our calculators have a log base 10 built into it. So these properties of logs will help us be able to figure out what the values are. And they will also be able to help us solve equations when we get to that point, which will be tomorrow, I believe. So here's our three properties of logarithms that we need to know. The first one is log base b of m times n. When we are multiplying inside of a logarithm, that is the same thing as taking both logarithms and adding them separately. So log base b of m times n is the same thing as log base b of m plus log base b of n. Okay, same thing. So when we multiply inside, it's the same thing as adding them. Log base b of m over n, so now we're dividing our logarithms. This is the same thing as subtracting them. Log base b of m minus log base b of n. Okay, so when we divide on the inside, it's the same thing as subtracting. These two actually look a lot like our exponentials, right? When we multiplied, we added our exponents. When we divided, we subtracted our exponents. So it's that same relationship. It's just inside logarithms now. And then this last one is log base b of m to the p. So p is a power. If we raise something to a power, that is the same as multiplying it by that power out in front. So that's the same thing as p times the log base b of m. So those are our three properties, and we're going to be able to use those properties to manipulate things to get it to exactly how we want it. One other property, or just thing we should note here, is what the log base b of b equals. Now, the way how we would convert this over to an exponential is we would think b to the what power is equal to b. So b to the what power is equal to b. Well, what's your exponent on there? 1. So it's b to the first power. So here, this also holds true. So if your base number is the same exact number as the value inside of the logarithm, you're equal to 1. Okay? So if the base number is the same number inside the logarithm, it's equal to 1. So what we're going to do is I'm going to give you what two logarithms are equal to, and then we are going to take a look at our values, and we're going to try to figure out what this should be. So we're going to try to use these properties to get it to work. So the two logarithms we know. Log base 3 of 5 is about 1.4650, and log base 3 of 20 is about 2.7268. So we want to find what the log base 3 of 4 is. Notice up here we don't have 4. We only have 5 and 20. So what we need to do is we need to figure out how we can get the number 4 using the numbers 5, 20, and we could use 3 because it has a base of 3, by either multiplying, dividing, or raising it to powers. Okay, so how can we get the number 4 out of 5, 20, and 3? Okay, so we could divide the 20 by 5. So we're going to rewrite this as log base 3 of 20 divided by 5. Mm-hmm. Yeah, they have to have the same base number for this to work out. So notice here, the two given ones have a base of 3, and this also has a base of 3. Okay, so now we use our properties. Our properties tell us that when we are dividing logarithms, we ultimately end up subtracting them. So this is really the same thing as log base 3 of 20 minus log base 3 of 5. Okay. And then we know log base 3 of 20 and log base 3 of 5 because it's given in our information. So all we need to do is we just need to plug in those values for it. So instead of writing log base 3 of 20, we would say, okay, that's 2.7268. And then we would subtract off our 1.4650.
Wait, what is that?
It's the same thing that's up there, 2.7268. And we'd subtract off our 1.4650. What do we end up getting? 1.2 what? Yep, 618. Okay, so instead of log base 3 of 20, we just plugged in our 2.2768. Instead of log base 3, we just plugged in our 1.4650, and we got it. Yep. Yeah, we're always going to go 4 decimal places for these. What was your question?
I was just going to ask if you could skip that one step of writing log base 3.
I would definitely write it out
Okay.
until you actually have it down. I would be writing it out. Okay, so log base 3 of 25. So now we want to make 25 out of the numbers 5, 20, or 3 with multiplying, dividing, or exponents. So how could we get 25? Okay, so we could square 5. So this is the same thing as log base 3 of 5 squared. Okay, and now our property of exponents say that this really, our power ends up being multiplied out in front. So this is really the same thing as 2 times the log base 3 of 5. Or our log base 3 of 5 is right here, so this is really 2 times our 1.4650. Because it's the power, so the power is going to go out in front and be multiplied.
Oh, yeah, because
So what would this end up being? So 2.9300. So we're always going to want to leave 4 decimal places. What's another option for how you could have gotten 25? You could not add 20 and 25 because our properties do not have anything over here that's adding. It is either multiplying, dividing, or powers. Those are the only ways how you can do it. You could have multiplied 5 times 5, though. That also would have worked. We would have gotten the same exact end result. All right. Those two okay? All right, so we're going to do some more. We still have the same numbers. We still have log base 3 of 5 and log base 3 of 20. Okay, so same exact numbers. So log base 3 of 100 now we want to find. So we can use 5, we can use 20, and we can use 3. So out of 5, 20, and 3, are there any of them that we can multiply, divide, or use exponents to get to it? Okay, so you could multiply what? All right, so log base 3 of 100 would be the same thing as log base 3 of 5 times 20. And then what does our property say when we are multiplying there? That we end up adding. So this is the same thing as log base 3 of 5 plus log base 3 of 20. And then we know log base 3 of 5 and log base 3 of 20. So we just add them together. So 1.4650 plus 2.7268. And what do we end up getting for this? Yep. So log base 3 of 100 is about 4.1918. That one okay? All right, we'll do one more of this type. Log base 3 of 45. So we have to make 45 out of 5, 20, or 3.
So you can only use the 5 and the 20, right?
You can use 5, 20, or you can use 3 because your base number is 3. Because our property said if the base number matches the number inside, it's equal to 1. So since our base number is 3, we also know log base 3 of 3 is 1. So we can use that number as well. So multiply, divide, exponents. What did you say? 5 times 9? Is that what you were also saying? Okay, so 5 times 9 worked, but then 9 isn't one of our numbers, so how do we get 9? 3 squared. So log base 3 of 45 is the same thing as log base 3 of 5 times 3 squared. Okay, so we first have to split this up to adding, okay, because only the 3 is squared, the 5 isn't, so we can't bring the 2 out in front yet. So we can say this is log base 3 of 5 plus log base 3 of 3 squared. And then what does that power of a square do there? Yeah, it goes out in front. So log base 3 of 5 plus 2 times log base 3 of 3. Log base 3 of 5, what is that equal to? Yeah, 1.4650 plus 2 times, what's going to be the log base 3 of 3? 1. So what will this be when we add it together? Yep, 3.4650. Is that okay? All right, so now we are also going to do some solving using our properties. Okay. To solve using our properties with logarithms, our goal here, in order to solve these, is to get some logarithm equal to a logarithm. Okay? So we don't want any numbers in front of the logs. We don't want any adding or subtracting in there. We want one logarithm equaling one logarithm. If we do that, then we can just make an equation of that stuff in the inside. Okay? That was like your last 2 examples on the worksheet for today. You had a logarithm equal to a logarithm. So you just made the equation of the stuff on the inside. So we're going to have to use the properties to get it written like that. So equation is 4 times log base 2 of x minus log base 2 of 5 is equal to log base 2 of 125. So we are going to want to rewrite this as one logarithm equaling one logarithm. Okay? So when we see numbers out in front, how can we put this back into the logarithm? Yep, that 4 out in front really ends up being an exponent. So we could rewrite this as log base 2 of x to the 4th minus log base 2 of 5 is equal to log base 2 of 125. Okay, so we still don't have just one logarithm here. We have 2 of them. It's attached with a subtraction sign. So the subtraction sign, we're going to write it how? As dividing. So we would write this as log base 2 of x to the 4th over 5 is equal to log base 2 of 125.
Is that because they have the same base that you can do that?
Yep, they all have the same base number of 2, so we need to be able to combine it all into one logarithm using our properties.
If they didn't have the same base,
Then we couldn't do anything if they don't have the same base.
Put the exponent into, like, oh, never mind.
So now that we have it as one logarithm written on both sides, we can make an equation. So here we just make an equation then of the stuff on the inside. So the stuff on the inside here is x to the 4th over 5 is equal to 125. And then how would we solve this? Okay, so times by 5. So x to the 4th is equal to 625. And how can we solve this? Okay, if we do the 4th root, we will be missing some answers. So we want to probably be careful about that. Okay, so we could just do the square root first. That'd be fine. So we have x squared is equal to, what's the square root of 625? Positive and negative 25. And we could do the square root again. Well, what's the square root of positive 25? Plus or minus 5. What's the square root of negative 25? Yep, plus or minus 5i. So there we do have 4 answers, and we had 4 powers, so that's the way how it should be. And then recall, we can only have positive numbers inside of our logarithm. So would any of these end up canceling because they're not positive? Yeah, which one are we left with? Yeah, we're just left with positive 5. What? Well, this should have 4 answers, so these would be the 4 answers, and sometimes some more of these answers might end up working. So we don't just want to cancel them out without even considering them. But we know that this has to be positive inside of our logarithm, and the only one here that ends up being positive is 5. Yes?
When you did the 5 times x to the 4th over 5, I don't get how you got like the 5s. When you took like the inside one.
How we got this 5 right here?
Yeah.
It was right here.
Oh, okay. Then how'd you get the other 5?
We times by 5 to solve it. We got rid of the denominator.
Okay, so
Yes.
Why do you have like this little unstressed symbols underneath it, where you just like underlining it?
Just underlining it. Yeah. X has to be a positive number because it's the inverse of an exponential. Our exponentials were like this, and y's had to be greater than 0. The logarithms are the inverses. So it's like that. So for that x has to be greater than 0 for logarithms. It's because they're inverses of each other. It will never exist over here. On your calculator, if you try to take the logarithm of any negative number, it doesn't work. Every time you're going to get error. There's nothing exists over there for it. All right, so let's do another solving one. Log base 8 of x plus log base 8 of x minus 12 is equal to 2. Okay, so here on the left-hand side, we would certainly multiply those two together because we are adding them. But what are we missing on the right-hand side? Yeah, we don't have a logarithm. So if we're missing a logarithm, we have to put one in. So what you want to do is you want to pay attention to the base number. So this is a base number of 8. So I can just multiply on a log base 8 of 8. Why does that not change the equation? Yeah, it equals 1. Okay, so if it equals 1, we're not changing the equation at all. We're just multiplying by 1. Okay, so anytime we just have a number, we want to make sure we multiply on our logarithm. And we use 8 here because we have the base number 8. So on the left-hand side, we're adding, so we end up multiplying. So log base 8 of, when we multiply x times x minus 12, what do we get? X
squared minus 12.
Yep, x squared minus 12x is equal to, now what would happen with this 2 out in front of the logarithm? Yeah, it would become the exponent. So log base 2 of 8 squared.
Why the second, the base?
Nope. I have no idea why the base went to 2. It was supposed to stay 8. That was a really good question. Okay, so now do we have the logarithms, one on each side? Okay, so let's make the insides equal. So our equation would just say x squared minus 12x is equal to, well, what's 8 squared? 64. Okay, we have an x squared and we have an x, so how are we going to be able to solve this?
You put the 64 over and you.
Okay, so we're going to subtract this 64 over, and then we're going to see if we can factor it. We should be able to. See x and x. Factors of 64 that subtract to give you 12. Good, 16 and 4. So how would we write this? X minus 16x plus 4. Good. So what are your two values for x here? Positive 16 and negative 4. So now look at both of those and look at your original equation. Will either of those make your original equation negative inside of the logarithm? Negative 4 will, so that will not work for a solution. So x is only 16 here. Is that one okay? Yes. All right, we'll do one more together. 3 times the log base 5 of x squared plus 9 minus 6 is equal to 0. Okay, we don't have a log on the other side, and we also just have this minus 6. So let's start by adding the 6 over. So 3 log base 5 of x squared plus 9 is equal to 6. And then what do we want to multiply the 6 by?
3
Yeah, log base 5 of 5. And why do we choose log base 5 of 5 this time? It equals 1 and the base number is 5. Okay, so what do we do with the 3 out in front of this log base 5? That goes to the exponent. So this is log base 5 of x squared plus 9 to the third is equal to the 6. So log base 5 of 5 to the 6th. Okay, we have a log equaling a log. So we have x squared plus 9 to the third equals, well, what's 5 to the 6th? You just didn't say that loud enough for me to hear. 15,625. Okay, let's be smart about how we solve this. Do you guys want to expand out the x squared plus 9? To multiply it by itself 3 times. Do you want to do that?
No.
Probably not. What's another way how we could get rid of the exponent then? This is to the third power. How can we get rid of the third power?
Can you square root it to the third power?
So cube root it. Yeah, you could cube root it. Cube rooting, do we have to worry about negative signs or positive signs when we cube root?
Yeah.
No, we don't, because the sign's going to stay the same. So then, so we have 15,625, and we need to figure out what the cube root of that is. So we're left with x squared plus 9 equals 25. Now that problem looks a lot more manageable. Okay. All right, sure, we can subtract the 9. So then x squared is equal to what? 16, yep. So then we could take the square root of it. So x is equal to plus or minus 4. So think about both positive 4 and negative 4. And put it into your original equation. Well, they both still give us positive answers in there. Yeah, they will this time. So that means both positive 4 and negative 4 are solutions. Why'd we what? For the cubed root? Well, when you think about something to the third power, the sign stays with it. So 5 to the third is 125. If it's positive, it stays positive. If you have negative 5 to the third, it's negative 125. So the sign stays with it. So since 15,625 was positive, we know the cubed root has to be positive. So we don't have to do the plus or minus how we do with the square root. Okay? All right.